So, my dear students, today we will discuss about a new topic, about the awareness of the organic compounds. In the previous class, we learned that the compounds of carbon and hydrogen and their derivatives are called organic compounds. But a question arises, or a question may arise in your mind, that why the compounds of carbon and hydrogen are so special that we have to discuss them in a different branch, or we have to create a branch in chemistry about the compounds of carbon and hydrogen. We will discuss about these things in this lecture. So let's start. Now we can see that the compounds of carbon and hydrogen, the number of the compounds of carbon and hydrogen is excessive high. In comparison to the other inorganic compounds, the total number of the inorganic compounds is only 1 lakh. So we can see that the total number of the inorganic compounds present in this world is only 1 lakh. But here in comparison, the number of only carbon and hydrogen is more than 80 lakh. That is, we can see that there are 180 elements in the periodic table, but only two elements, carbon and hydrogen, creating a lot of compounds, the number of which is more than 80 lakh. So as there is so much number, so there is something to do, or we have to discuss them separately, as there are vast number of compounds in with only these two elements. So now the question is, why what is the reason behind this, or why the number of the organic compound is so high, or the number of the compounds of carbon and hydrogen is so high. We have to discuss about this. There are three reasons behind this, why the number is so high. We can find three reasons for this, that for these three reasons the number of organic compounds is so high. The three reasons are: first is catenation. Catenation is the car- co- compounds of carbon. The carbon can form a large chain. A lot of carbon elements can be connected between them, can form bonds between them, and a lot of carbons can connect between them, or form bond between them to create a large compound, and this is called catenation. And anyone asks if anyone asks you what is the reason behind the so much number of the organic compound, the answer will be catenation. For the catenation, the number of the organic compounds is so high because carbon can form a large chain. We will discuss about this later. Isomerism and polymerization. So there are three reasons for this: catenation, isomerism, and polymerization. And for these three reasons, the number of organic compound is so high. So let's discuss about these topics. The first topic about this is catenation. What is catenation? Catenation comes from a Latin word. The meaning of the Latin word catena is chain. It came the word catenation came from a Latin word. The Latin word is catena, and the meaning of the catena is chain. A lot of carbon atoms can form bonds between them. A lot of carbon atoms can form bonds between them, and they form a chain by creating this bond. And this is called catenation. For example, we can see that a lot of carbon can form bond between them, and this capacity of forming bond between the same elements, or this capacity of forming a chain between the same elements, this is called actually catenation. A lot of carbon elements can form bonds between them, and this is called catenation. This chain is different type. They form a straight chain, they form circular chain or closed chain, they form single bond, they can form double bond, triple bond, etc. Different type of bonds they can form. And this is the primary reason the number of organic compound is so high. So the capacity of catenation is actually mainly seen in the carbon elements of the carbon, or atoms of the carbon. But silicon, a group member of carbon, that is group 14, silicon also shows some properties of catenation. In silicon dioxide or some other compound, they can form this type of this type of chains. They can form this, creating this bond. These chains are different. We will discuss about the different types of chains. One of the type of the chain is open chain and saturated compound. Open and saturated, open chain, saturated, etc. This is propane. Propane is an example of open chain compound and saturated compound. This is the example of both of these. What is meant by open chain? By open chain, we can see that there is a chain of carbon, but there are two terminal carbons. At each end, it is not connected with any other carbons. That is, there is an end of this carbon chain. If there is an end of this carbon chain, this is called open chain. You can learn it from the comparing with it with closed chain compounds, it will be easier. In comparison, there in the closed chain organic compound, there is no end of this chain. You can see the carbon, each of the carbons of this bond are connected with each other, and there is no such terminal carbons. See, in benzene, this is benzene, this compound is nothing but benzene. You see, in benzene, there is no terminal carbon, but here in propane, there is terminal carbon. So, if there is a terminal carbon in any chain, this is open chain. And if there is no terminal carbon and this is a circular or closed, then it is called a closed chain. Then, the different type of chain, there are different type of chains. One type is saturated and unsaturated. This is actually, this classification is actually depending on the nature of the bonds present. It is classified into two types, saturated and unsaturated. What is saturated? You see, here there is only single bond, no carbon carbon double bond or triple bond is present, only carbon carbon single bond is present. If only carbon carbon single bond is present, then it is called saturated compound. So I think you are clear. Only carbon carbon single bond is present, then it is called saturated compound. Then what is unsaturated compound? If carbon carbon double bond or triple bond is present, you see in here, this is propene, this is propene. In propene, you can see there is carbon carbon double bond is present. So the presence of double bond or triple bond, it makes the compound unsaturated. Actually, the unsaturated compounds are more reactive than the saturated compounds, as the double bond or triple bond is less stable, and they are called unsaturated as they have the capacity of connecting more hydrogen atoms together. I think you could understand it. Open chain, closed chain. There is there is also a diversified type. The catenation of carbon is a lot diversified, and a very good example of this diversification is fullerene. Fullerene is also a type of the catenation. Here we can see a lot of carbon atoms, a lot of carbon atoms. So each of these balls actually we are seeing in this picture are actually carbons. Each of these carbons are actually connected with each other. Each of these carbon are connected with each other, and by connecting this, they are forming a large compound. They are forming a large chain of carbon, and this is fullerene, and it is a good example of the power of the catenation of the carbon, that how powerful or how strong catenation it can form. One question may arise that why the catenation is so much successful in carbon rather than other elements. The answer is the bond energy of carbon carbon is so high. That is carbon carbon bond energy. The bond carbon forms with other carbon carbon bond energy. It is so high, and as the bond energy is so high, so the bond is also very stable. And as the bond is very stable, a lot of carbon can be connected with each other. As the bond is very stable, a lot of carbons can be connected with each other, and by connecting these a lot of carbons with each other, they can form a large chain, and this chain is stable and does not break so easily, because the chain is stable, the bond is stable. As the bond is stable, the chain becomes stable, and that's why the catenation is so much successful in carbon in comparison with other elements. There is no very good example of so diversified form of catenation. I think you understood this topic. Our next topic is isomer. The next cause for the large number of organic compound is isomerism. What is isomerism? We know that isomerism is the compounds which have same molecular formula but different structural formula are called isomer. And by forming isomer, organic compound again increases the number of their compounds. For example, C2H6O. If a normal inorganic compound with the same formula, for example in H2O, H2O only represents only one compound, that is water. But C2H6O, the same molecular formula, can represent two different or can form two different compounds, totally different compound. One compound is ethanol and another compound is dimethyl ether. Ethanol is a liquid and dimethyl ether is a gas, and ethanol is a polar compound, dimethyl ether is a non-polar compound, and there is no similarity between these two compounds. This is isomerism, and isomerism is a very good cause of so much number of organic compounds. I think you understood this. And the last cause behind the so much number of organic compound is polymerization. What is polymerization? Polymerization is a lot of ethene monomers or single units or smaller molecules can connect or can form bonds between them. A lot of smaller organic compounds can form bonds between them to form a large organic compound. You see here ethene. Some ethenes are present and these ethenes are connected with each other to form a polythene. For example, here you can see there is a double bond in this here. You can see a double bond. If this double bond somehow breaks, then one hand of this carbon and one hand of this carbon, or one valence of this carbon and this carbon is broken down, and so these two carbons has an open hand. If also this double bond breaks down, they have also one free hand, and with this free valency or free hand they can connect with each other. And by forming this, they can form a large compound. A lot of monomers can connect between them to form a large compound, and this is called polymerization. By the forming of polymerization, the number of organic compounds thus increases blindfoldly. So this is the causes of the so much number of the organic compounds. Now let's get a summary. So today in this class we learned about the abundance of the organic compound. We can see the number of the organic compounds is so high, that is more than 80 lakh. It is a good MCQ that comes in your exam. The number of the inorganic compound is smaller, only 1 lakh in comparison to the organic compound. So what is the reason behind it? What is the reason behind the so much number of the organic compound? The reason is 3 reasons for this: catenation, isomerism, and polymerization. Catenation is the property of formation of chain. A lot of carbon atom can form chains between them. Other than carbon, silicon also shows this property. There are different type of chains: open chain, there are 2 terminal carbon; saturated, only single bond is present; unsaturated, that is there is only double bond or triple bond is present. In spite of single bond, double bond or triple bond is also present here. A closed chain organic compound. In the closed chain organic compound, there is no terminal carbon. Every carbon is attached with each other. This is closed chain organic compound, etc. Fullerene is also a different type of catenation present in the compounds of the carbon. A lot of carbon atoms are connected between them. Isomerism. The second reason behind so much number of organic compounds is isomerism. What is isomerism? Molecular formula is same but structural formula is different. Polymerization. Organic compounds can form also polymer. What is polymer? A lot of monomers are connected with each other to form a giant molecule, and this is called polymer, and the process is called polymerization. Due to polymerization, the number of the organic compounds also decreases further. The number of the organic compounds also increases further. That's all. You will correlate this lecture with the study books or NCTB books that are found in the library. Actually, correlation with this lecture and the book will give you the maximum benefit while learning. Thank you all.